Okay, so we're going to be talking about greatest common factors and factor by grouping. And so GCF, this stands for greatest common factor. And this is by far the most common type of factoring that we're going to end up doing whenever we factor. It's not just an end of itself, but it also gets to be a step in some other types of factoring. Now, what we're doing when we factor is we're breaking up some other statement. Say we've got like 8x cubed minus 12x squared. What we're doing is we're splitting this whatever statement into the product of two or more things. Greatest common factor, what we're going to be doing is we're first going to find the largest number that divides, I can spell, all of our coefficients. So between 8 and 12, I could see that I could divide both of these by 2, but I also see that 4 would go into both of them. 4 is the biggest one. So 2 would be a common factor, 4 is the greatest. So I'm going to factor out a 4. Then we're going to find our common variables. And all it means to be common is that it's in all of them. When we talk about like common factors, it's not that, oh yeah, this is something that's kind of ubiquitous. It's something that's in all of them. So I've got x's in both of these. And when I do this, I'm also going to choose the lowest power that's present. So I've got an x cubed and an x squared, so I'm going to factor out a 4x squared. And essentially what we're doing is we're dividing each of these things by that 4x squared. Or I might be saying 4x squared times what is going to be 8x cubed. Well, 4 times 2 is 8, and x squared times x is x cubed. 4 times 3 is 12, and if I don't have any other x here, minus 3 times that 4x squared would give me that minus 12x squared. That's a 2 there. So we're done. This is all it means to do greatest common factoring, to actually factor out that greatest common factor. And if, for example, we hadn't taken out the greatest common factor, you'd be able to repeat this process again. It's messier, but you could do it. So think about this. If I have something like this 8x cubed minus my 12x squared, and I said, oh, I could factor a 2x out of that, you'd be able to see that we would still be able to look at this, look at what I have left over in here and say, oh, look, I see 2 is still a factor here. So I'm going to say, oh, that's going to be like a 2 is here, and I can have another x, and that would be times our, actually I'm just going to do this, 2x, and that would be times our, this, 2x minus 3. Well, guess what? That original 2x stuck around. So what would happen is I would then have to go through this, and I only want one set of parentheses here. This is kind of sloppy, so we're just going to go ahead and multiply this 2x and that 2x. So we'd end up with our 4x squared. So if you don't get your greatest common factor at that first pass, like we did here, so here we factored a common factor, not the greatest. And greatest just means the biggest one that we can legally pull out. All right. Let's do another one. And there's a couple things that I always like to point out. Sometimes you're going to end up with some stuff that might be a little harder to determine what's going on. So, for example, what happens if I've got something like 3x squared minus 5xy plus 2x? Now, if I look at all three of these, I'm looking for a number that goes into all of them. And one of the things to note that is that if there is no number that divides all these coefficients, one is always something that will go into them. So I could say, oh, I've got a 1 that I can pull out. Okay, well, 1. And I still have an x in all of these. So I'm going to just also pull an x out. 1 divides everything. Okay, so this is going to be 3x, because x times x is x squared, minus 5y, and then plus 2. And we're done. Something else that's very important to remember is that, say I've got something like 5ab plus 15a squared b. If I'm factoring this, I'd say, oh, I see that 5 goes into all of these. I've got an a in both of these, and I've got a b in both of these. I'm starting with 2 terms, and if I'm just doing greatest common factors, I should have 2 terms inside my set of parentheses. So when I factor this out, this term doesn't go away, it just becomes a 1. 5ab times 1 is 5ab. I know some people want to just sort of hand wave and say, oh no, I just took that out. No. You're dividing by this 5ab. 5ab times something is going to be 5ab. And as we just said, 1. 5ab times 1 is 5ab. And then I've got a 3a. So 5ab times 1 is 5ab. 5 times 3 is 15. A times a is a squared. And we've got the b there. So that's some subtle things, or some things that I've seen some folks decide that for some reason that we shouldn't have 2 terms in here. But this is the beginnings of this is what we do with this greatest common factor type of factoring. Now, let's put this into practice with something called factor by grouping. And factor by grouping is interesting. We're going to notice when we start this, I'm going to point something out. If I had something like, say I've got like x, y minus 3x, or actually it's minus 3y. If I were to factor out my greatest common factor, I could say, well, let's factor out a y, and then I'll have that x minus 3. But I'm going to say something here. A binomial can be, or any polynomial can be, a common factor. So instead of x times y, how about I have like x times x plus 4, and then minus 3 times x plus 4. Even though this is a binomial, it's the same thing that's multiplying both of these terms. So I can factor that out just like I did here. I could factor out that x plus 4, and I've got my x minus 3. So this is the process that we're just sort of pulling out a common binomial. This is actually just another type of greatest common factor. The greatest common factor in this case was x plus 4. Well, let's take this one step further. What happens if I've got x squared plus 4x and then minus 3x minus 12? What we're going to do is we're going to factor the greatest common factor from our first two terms. So from our first two terms, that's an x, and that'll be x times x plus 4. I'm always going to include this middle sign. So I'm going to include our middle sign. So I'm going to factor out, whatever I'm going to factor out, I'm going to factor out a negative, and then I'm going to factor out that greatest common factor from our last two terms. So if I look at that, I'm factoring a negative 3 out of both of these. Now, this one's a little bit trickier if I factor out a negative. Negative 3 times what is minus 3x? Oh, negative 3 times x is that. Negative times a negative is positive, so I'm going to factor out, negative times negative is positive, but negative times positive is negative. So I'm basically, when I factor out a negative, both of these signs flip. So I'm taking out a negative from both of them. Negative 3 times x is minus 3x. Negative 3 times 4 is minus 12. And this should look fairly familiar, especially since it's right up here at the top of the page. And then we're going to factor out our common binomial. So now what I'm factoring out is that x plus 4, and I've got my x minus 3. Let's do this one more time. I'll give you one more example here. And I'm going to go for 6x squared minus 15x plus 4x minus 10. You unmuted yourself. Pardon? Okay, so when we're doing this, I'm going to first pull out my greatest common factor, and that's going to be a 3x, and I'll have 2x minus 5. And then out of these last two, I'm going to factor out a 2, and that'll be x minus 5. Finally, I will factor out, oops, sorry, that's a 2 times 2x minus 5. Now I've got that common binomial I can take out, that 2x minus 5, And I've got my 3x plus 2. And we're done. Alrighty.